Okay, so last video we talked about the angle of elevation. Now we're going to talk about the angle of depression, which is very similar. So essentially, angle of depression is the angle between the horizontal line and the line of sight to an object when you're looking down. So if we're up in a hot air balloon looking down at a person on the ground, the line straight out from us is our horizontal line. And the line we look down at is our line of sight. And together those two lines make the angle of depression. Now, something that's pretty cool is that the person on the ground looking up at the hot air balloon is making an angle of elevation, right? And that angle is going to be the same as the angle of depression because these two lines are parallel. The horizontal lines are parallel, so we have alternate interior angles. The angle of elevation and the angle of depression are alternate interior angles made by the two parallel lines and the line of sight going through it. So we know those two are going to be congruent to each other, which is something that will help us out in these problems to make triangles that we understand a little bit better. All right, so let's go ahead and practice some. So we got a little boy standing on a cliff, and he sees a boat that is 200 feet out on the water. So there's water below the cliff, and we've got a boat out here. I'll just make it a little sailboat or something. So he's looking out at this boat. All right. Now, we draw the horizontal line and his line of sight, and we know that that angle that is made there, see, well, that's actually what we're trying to find. What is the angle? So we're trying to figure out what is this angle X. They tell us that the boat is 200 feet from the cliff, and the boy is 315 feet from the cliff. So here's the issue. We've got this, we don't want to necessarily have our triangle upside down. So if you like your triangle to be right side up, we can see we've got this triangle going right here. So what we can do is change X down here at this angle, because we know the angle of elevation up to the boy from the boat should be the same as the angle of depression. So we can convert our triangle like this, because it's sometimes a little bit easier to see the triangle like that instead of doing it upside down. So now let's determine which trig function we should use. Well, this side over here is our opposite side, and this is the 90, so 315 is our hypotenuse, which makes 200 the adjacent side. So we're using the adjacent side and the hypotenuse. Well, using SOHCAHTOA, so with a silent H, co with a silent H, and then TOA. Since we're using an adjacent and hypotenuse, we should use the trig function that starts with a C, which is cosine. So cosine of X, the angle, should equal the adjacent side 200 over the hypotenuse 315. So you got to remember, how do you get rid of the trig function to find X? Well, that's the inverse trig function. So we're going to do inverse cosine, and that'll cancel cosine on the X. In our calculator, we have to hit second cosine 200 divided by 315. When we do that, we get 50.58, so we can say 50.6 degrees. So that's the angle that the boy's going to have to look down at, his angle of depression, to be looking at the boat. All right, let's go on to another one. Nice, this one's got the picture drawn for us. So Princess is on the top of a 167-foot tower. So we know this tower is 167 feet, and she's looking down at a 37-degree angle at a package attached to the rope that she's holding. So this is her rope that she's holding right here, and we want to know how long is the rope. So this is X. And again, this angle of depression at 37 degrees is also the angle of elevation coming up from the package. So we can call this 37 degrees down here. So which trig function would we use? Well, this is our right angle. So X is our hypotenuse. And then across from our angle is our opposite side. So that's what we're using, the opposite and hypotenuse. Using SOHCAHTOA, we know that's sine, because so is S-O-H. We need O and H goes with the S, so sine of 37 degrees equals the opposite side 167 over the hypotenuse X. Right? So this is one of those problems where your variable's on the bottom. And the variable's on the bottom. Remember, we're just going to swap it with sine of 37. So do 167 divided by sine of 37 on the calculator. Now, not inverse sine, okay, this is just regular sine. We only use inverse sine if we're canceling sine. We don't have to cancel sine right here. So we're going to do 167 divided by the sine of 37. And we get 277.49. Or we could say 277.5 feet if we want to round it to the tenths. It just depends. They might tell you what to round to the tenths, the whole, the hundredths, whatever. So they didn't say right here, so we're just going to round it to the tenths, 277.5 feet. Let's do this next one, number 7. From an airplane at an altitude of 1,200 meters. So this airplane is 1,200 meters from the ground. The angle of depression to a building on the ground measures 28 degrees. So this is 28 degrees. We want to find the distance from the plane to the base of the building. So that would be this line X. Okay, so again, this angle of depression, 28 degrees, is going to be the same down here as our angle of elevation, so that's 28 degrees. So now looking at this triangle that we make, which sides are we using? We're using the opposite. So that's across from our angle. Here's 90. X is across from 90. That's the hypotenuse. So again, we're just like the last one, using opposite and hypotenuse. So sine of the angle, sine of 28 degrees, equals the opposite side, 1,200, over the hypotenuse X. And then we do what we did on the last problem, we swap them. So X equals 1,200 divided by the sine of 28 degrees. 1,200 divided by the sine of 28 degrees gives us 25.56. Sorry, gives us 2,556. And that's in meters. So 2,556 meters is how far the plane is from the base of the building. Let's do one more and then you guys can try some. A sonar operator on a battleship detects a submarine, oh that's kind of cool, at a distance of 500 meters horizontally. So the distance the ship is from the submarine is 500 meters. And at an angle of depression of 37 degrees. Okay, so it's really important that you notice it says horizontally. That means the distance going out horizontally, not the distance going down at the angle of depression. So just know it's 500 meters out horizontally. And we want to know how deep is the sub. So essentially, we want to know how deep is the sub. So that's going to be our X. Alright, so which trig function should we use? Well, here's 90, so this angle is the hypotenuse, which we don't use. Opposite the angle is X, and the only one left is adjacent. So using SOHCAHTOA, which trig function uses the O and the A? O and A is the one that starts with T, tangent. So we'll do the tangent of the angle, 37 degrees, equals the side that's opposite, X, over the side that's adjacent, 500. And the variable's on top, so we just multiply by 500. So X is going to equal 500 times the tangent of 37. And that should give you 376.77. Or you could round it and say about 377 meters. So that's the depth of the sub. Okay, again, make sure your calculator is always in degrees when you're doing these. And be sure that you pay attention to which sides you're using to know which trig function to use. Use SOHCAHTOA to figure that out. It'll help you a ton. All right, go ahead and practice these next couple on your own, and we'll go over them. All right, so we got the escalator problem here. When we draw it, we should draw the escalator is 110 feet long, and it's 32 feet from the first floor to the second floor. And we know what's the angle that the escalator makes with the second floor. So that is this angle right here, okay? So when we want to know that angle, it's our angle of depression, we can just bring it down here and use it as the angle of elevation in our triangle. So bring x down here, and then we can set it up because 32 is the opposite side from x, and 110 is the hypotenuse. So opposite and hypotenuse, using SOHCAHTOA, tells us to do the sine of the angle. Well, the angle we don't know is x, so we do sine of x equals 32 over 110. And then you got to do the inverse sine to get x by itself. So we do inverse sine of both sides. Inverse sine of 32 over 110 should give you 16.9 degrees. So that's the angle that the escalator is making with the second floor. Next problem, you've got a rock that's dropped from 182 feet from the top of the Leaning Tower of Pisa, and it falls to a point that's 14 feet from the base of the tower. So you can see I drew my tower right here. It's 182 feet, so we got a very thin right triangle right here, which is okay. We just got to be able to visualize it. So we got 182 as the height, and it falls 14 feet from the base of the tower. The question is, what's the angle the tower makes to the ground? So basically, what's the angle it's leaning at right here? So we can call that x. Again, we're finding the angle. So opposite of the angle is 182. 14 is adjacent because this right here is our hypotenuse. This right here is our right angle. So we do the tangent because opposite and adjacent is tangent because of TOA. TOA, T-O-A. Opposite and adjacent is tangent. So we do tangent of x equals 182 over 14. And then again, you've got to find the angle. So you've got to cancel tangent by doing inverse tangent. So inverse tangent of 182 over 14 should give you 85.6 degrees. That's the angle that the tower leans at. I appreciate your all's time and attention. Let's go ahead and practice some.